Okay, we want to continue on and look at global pressure systems. Now, remember, the wind is caused by differences in air pressure, so it's important to know where these different pressure systems are. Um, so let's go over to share screen. Okay, all right. So there's some primary high, and some primary low pressure areas. The most important one is going to be what we call the ITCZ, the Intertropical Convergence Zone. It's a low pressure right by the equator. A little bit on, excuse me about that, a little bit on either side of the equator. There's a low pressure in the northern hemisphere and a low pressure system in the southern hemisphere. And where they converge around under the tropics, under 23.5 degrees south and north, where they converge, that's the intertropical convergence zone. It's going to be very warm and very wet there. The other main one is what we call the polar high pressure, which is up at the North Pole and the South Pole. It's very cold, very dense air, so we get the air, it's a high pressure, so the air descends down and then diverges out. And that is the big movement. So it goes down from the polar high down to the equator, where it rises back up at the ITCZ and works its way back to the equator. Now, in between those, there's another high pressure, the subtropical high, right above the tropics, and the subpolar low pressure, which is a low pressure right beneath the Arctic Circle. Okay, now what I want you to do, make sure, is to look at these two animations on the chapter module, the global pressure patterns. It's an animation that'll show you how all these pressure systems work, where they are in terms of their latitudes. That's important to know. That's going to be all over the tests. And then the wind animations, which shows you the general wind patterns for the whole world. Okay, so here's the ITCZ. Now it moves with the sun. When the sun is in the northern hemisphere, the ITCZ will rise up with it. When the sun is in the southern hemisphere, in our winter, their summer, it will go down into the southern hemisphere. And notice the amount of precipitation. So the yellow, or the more precipitate, or the red, I should say, is the more precipitation. So you can see all along the ITCZ, we get these very, very wet climates down through here, lots of precipitation in the rainforests in South America, in Central Africa, and over here in Indonesia, and also up here in this part of Southeast Asia. And then you can look at the barometric pressure in millibar. Remember, 1013 is normal. So the ITCZ here, this low pressure up here, notice it's about 998, okay? So that will give you some indication of how these move back and forth. So again, make sure and watch that animation on the course module. Okay, and so you can see it again. Here it's up in this is our summer, so that the ITC has gone up. And you can see, the monsoonal rains here in South Asia, all the way extending all the way over to the Philippines and all the way over here into Indonesia, and all the way through the rainforests here. So notice here's the Pacific high pressure. Okay, so normally this is the subtropical high. The subpolar low is going to be up a little further. It's going to disappear in the summer. But notice, again, 1013 is normal, so notice that this is higher than usual. And this is what provides the weather for Southern California. It's going to be dry, so during our summer months, that's is a contributing factor to why we get our dry weather. And again, I can't stress this enough. Make sure you watch that global pressure systems animation in the course module. Here's just the characteristics. You can go through this on your own. The slides are there in the module. But the ITCZ, like we said, it's going to be wet and rain, or warm and rainy there. The moist air rises over the equators, cools down, and produces heavy condensation and rainfall. Now, around 20 degrees north, and again, the animation shows this very clearly, some of the air, north and south, some of the air descends, and this is what forms the high pressure cells in the subtropics, and we call these the Hadley cells on either side of the equator, where this air circulates between the equator and the subtropical high. Then the rest of it goes all the way up to the North Pole and then comes back down and makes its way down to the equator. So ITCZ, low pressure, warm and rainy. These subtropical highs between 20 and 35 north and south, generally clear and cloudless, and these are what are powered by the Hadley cells. So again, make sure you watch that animation in the course module. Then subtropical high cells, again, hot and dry. Usually the one in the Pacific is called the Hawaiian high. The one in the Atlantic, it moves back and forth. It's got seasonality, so it's Bermuda or Azores high, migrates with the sun. Okay, and again, they're drier and more stable with cooler ocean currents. Oh, and I should point out, on the western sides of the continents, that's where you're going to see you have cooler ocean currents and this dry air, so very little moisture, and that's where you tend to see the world's deserts. You know, our southwestern deserts and the Atacama Desert in South America, for example, are the results of this. And subpolar low is a low pressure around 60 degrees north. And again, we usually call it in the Pacific the Aleutian low, in the Atlantic it's called the Icelandic low. And it disappears in the summer because the sun comes up into the northern hemisphere and disperses that low pressure. But usually it's going to be cold, cool, and moist. And this is kind of what provides the moist weather for, like, say, Seattle and Vancouver in Canada. Okay, so, and then further up north, all the way at the top and all the way at the bottom, are the polar high pressure cells. Again, they're weak, but they're very cold and dry. You have to think of the Arctic and the Antarctic basically as deserts. It's not snow; it's just blowing ice that we see, and it's just totally dry up there. Okay, and then this is kind of what it looks like. So here's your ITCZ. Here's your subtropical high. There's your subpolar low, and then there's your polar high. Okay, and then the ITZ will migrate with the summer. With the sun. It'll go up here in the summer and down here in our winter, and carrying that rain with it. In the summer, when the ITZ is up here, this low will disappear. This high moves up a little more, and this is what provides the weather for where we live here in Southern California. Okay, and here's our Hadley cells, this motion of air between the ITCZ and the subtropical highs. So again, make sure you watch the animation in the module that shows you this in motion. It's very, very good. Okay, so we'll stop here and then do upper atmospheric circulation next. So we'll go back out of share.